Good morning. All right. Let's now talk about some stuff to pay attention to. For your programming test one, which you guys did yesterday, I'll try to return the result back to you shortly after the reading week. So me and the TAs will be busy grading during the reading week. So you can expect to hear from me very soon after the reading week. For your lab number two, I'll release it either by the end of Thursday, tomorrow, or early Friday. So you still got about 2 weeks to do it. Lab number two would be a little bit more challenging than lab number one because we do have incorporated exceptions in lab number two. But that's something you can maybe plan some time to dedicate during the reading week. And for your reading week, I think apart from catching up with your lectures and do lab number two, I don't have any other thing to suggest. But I'm going to write an announcement tomorrow or on Friday just to remind you what you can do during the reading week. But might be a nice time for you to take a break as well, as usual. All right, let's now continue with our lecture about testing and exceptions. Okay, so these are the two exceptions that we got from last time. Let me just remind you very quickly. So we got these two exception classes, value too large and also value too small. We're going to make use of these two exceptions a lot today, right? We're going to see lots of examples, especially how we can trace the different execution flows when you actually got exceptions. And the extra complication we have today is we are now adding exception for the purpose of testing. And that's something I'll explain a little bit further. All right, so we talk about how you can do either specify or catch, right? That's something we did last time. And this is where we left off from last time. Let's now introduce a little bit more model classes, and then we will be able to do various testing. Okay? And let me switch to iPad right away. Okay. Let me now go over the counter class with you, which is rather straightforward, but that's something you should know the detail. Otherwise, you wouldn't really get a testing later. All right, so we have a counter class over here. We have two global static variables. And I'm pretty sure you have seen the keyword final, maybe from the first year, right? That means the variables will never get changed. It's simply a constant. We don't really mean to change them, just constant. So let's say this is really important. For our purpose, just remember, the lower bound, the lowest value the counter can get into will be 0. The highest value you can get into will be 3. Just remember that. We need that kind of constraint for today. And we got integer value, private, because you can see it's non-static. And we got counter constructor, and initially the counter will be initialized to 0 over here. Starting from 0 and all the way to 3, and then maybe back to somewhere in between. And simple accessor, just to get a current value for the counter. All right? And let's now take a look at more closely about the two methods we have to test. One method called increment, the other one called decrement. And we use the specify option over here. Right? So whenever you want to increment, if you try to increment when the counter already reaches its maximum, of course, you cannot really increment any further. In that case, you're going to throw value too large exception. Right? You can see when the value is equal to the maximum value, we're going to throw the exception. Otherwise, we can increment. For example, if the current value is 0, of course, you can increment to 1. If the current value is 3 already, you cannot increment any further. Right? So these are two different scenarios. Symmetrically, we also got another mutator called decrements. In that case, if the current value is already the minimum 0, you cannot decrement any further, in which case we're going to throw value too small exception. Otherwise, let's say if I got the current value being 2, I can decrement to 1. Right? So these are the two mutators. Any questions so far about the two methods? That's all we got for the counter class. All right? What you need to be clear about is, sometime you can, maybe once you go back to study this lecture, think to yourself why the if condition should be laid out in this way, and this one should be laid out in this way. But for now, you can take it for granted they are both correct. Okay, let me emphasize that. This condition here, and also this condition here, they are correct. However, for our testing purpose, let's say we want to test the counter. You can never assume whatever, let's say you're the software tester, you want to test maybe some people's code, which was not written by you. In that case, you can never assume the code given to you will just be correct. A very good test should do the following. Number one, if the implementation is correct, you should confirm it by giving a green light. Number two, if the implementation was incorrect, you should really signal a red light to say there's some error, right? Either way, depending on whether or not the counter implementation is correct. In this case, they are correct. But we're going to see later, if you try to modify the implementation just a little bit, is it going to trigger some different execution path in the corresponding test so that some error can be signaled? That's something we'll see today, right? That's kind of the theme for today. All right, any question you want to ask before we dive into more examples? We've got a lot of examples to talk about, more challenging for sure. Okay, let me see the slides. Yeah, everything has been mentioned. Just remember this requirement. The value should be between 0 and 3. And there will be two exceptional scenarios if you try to increment when you already reaches the upper bound, or you try to decrement if you already reaches the lower bound. Right? And these are the two mutator methods we just talked about. All right? Good. Let me just give you some little bit general information, and then we'll look at specific example. What will be the components of a test? Every time you try to write a JUnit test yourself, think about informally what you really mean to test. Sometimes you might only mean to test some normal behavior. Sometimes you might mean to test some abnormal behavior. Both are possible. I'll show you both. Okay? Let's now go over some ideas, and then we'll see Java code. You want to manipulate the relevant objects, in this case, the counter. Right? We want to create instances of counter. Example number one. You may want to say, I want to initialize a counter objects. Then I want to call c.increments. What's going to happen? For example, you might say, after initializing the counter object c.getValue should be 0 initially, right? After I say c.increment, c.getValue should become 1. That's basically what I want to test. I want to make sure everything I expect about the counter should be returned back to me as expected. What about abnormal behavior? Let's focus on this one. This might be a little bit new to you. Let's say I initialize a counter. Initial value should be 0. And I try to call c.decrements. What would be the correct behavior of the increment? In this case, the increment should throw some value to small exception. That should be the expected behavior. So that's why I highlight one as green, the other one as red. Both are valid scenarios you want to test about the implementation of your counter. But in green, you do not expect any exception to be thrown. In red, you do expect some exception to be thrown. That's a very fundamental distinction you want to make whenever you want to write a test or to read a test. This will be kind of the scenario you will see a lot in lab number 2. So I'm also trying to get you prepared to do lab 2. All right, so just remember, we got these two fundamentally different scenarios to test. Oh, what do you expect to happen? For the first one, you just expect the counter value to be incremented, right? The second one, you do expect some relevant exception to be thrown. And how do you check to see what your program will actually produce in order for you to do maybe assert equals? You just call the get value, right? So for the green, because we do not expect any exception to be thrown, just call c.getValue to see if the value will be incremented from 0 to 1. The second one will be interesting. That's something to be discussed in much greater details. You have to use the try and catch block to do such testing purpose to say, if the expected exception has been thrown, it's a success. Otherwise, if that expected exception was not thrown, it would be considered as an error. How do we do that kind of logic using try and catch block? Interestingly, you already learned it implicitly back on Monday. But I'm going to reinforce that today. Right? It's so important to get that kind of tricky logic clarified. All right, so a test will actually pass if the expected outcome might occur. So don't really get too narrowed. Whenever we say expected outcome, again, expected outcome could be maybe the return value from some method should be as expected, or the expected outcome could be some exception is thrown. Right? Either way, right? Keep emphasizing that. Well, it failed if it does not occur. And for now, just to start with, let's do some console tester, meaning that we're going to maybe just signal whether or not the test is actually success or failure just by printing out some message to the console. Later on, we can easily adapt those tests in the console into JUnit just by replacing some line with the relevant assertion. So it's rather straightforward. But for now, let's focus on console. And then I'll also run both paper and also Eclipse to show to you. It's so important to get it right. All right, the first one. Let me just go to here, all right? Before I say anything, can you guys just please take a look at what we got over here, okay? We got counter tester 1. It's a console tester because we got the main method, right? And can you read from line number 3 to line number 12? Oh, 3 to 11. I'll give you 1 to 2 minutes, okay? Read it first, have some idea, and then I will go through it. Especially, even before I try to guide you a bit, think about why I will put error over here and why I will put success over here. That's something you want to focus on, if you can convince yourself. If you're not too sure, that might be the point you want to pay attention to for today. All right. Okay, I'll give you maybe another 30 seconds or so. All right, okay. Yeah, for those of you who just arrived late, I'm just basically talking about how we can use a console tester to test for normal versus abnormal behavior. That's something you can maybe watch the recording later just to catch up, all right? And let me explain why I need this page over here before I trace any code. It's important for you to know the following. This decrement method over here, think about you are the tester, right? Your only job is to do testing. You're not really responsible for the implementation that's sent to you for testing. It might just be done by somebody else. There are two possibilities, apparently. Either the decrements that's written by somebody else was implemented correctly, or the decrements was implemented incorrectly by somebody else. Your test, the main job, well, to judge whether or not your test is really correct, you have to say, if the decrement implementation is correct, I'm going to say success. If its implementation is incorrect, I'm going to say error. That's the idea, right? What will be the expected behavior in this scenario? Let's take a look. What we're doing here is, line number 3, we are simply just creating a counter object, C. And then line number 4, since we are doing some testing just on the console, what we're doing is we want to print out the current value for the counter to the console. We can just check by our eyes, make sure it is 0, right? And then we're gonna see the decrement over here. And the reason that we must have the try and catch block is because the decrement method here, if you remember, it throws value to small exception, right? So that's why we're gonna specify it. Well, sorry, it's specified, okay, let me show you here. The decrement method here chose to specify the exception. So now in this caller over here, we just choose to catch it, right? Just to be more precise. And if the implementation was correct, in that way, do we expect some exception to be thrown? We do. In that case, we shouldn't expect us to reach this line. Agree? In that way, we should really expect this line over here somehow at the end, some relevant exception will be thrown, so we get all the way to catch and then continue. And in that case, we'll say success. That will be the scenario when the decrement was implemented correctly, symmetrically. Another scenario. We get to the decrement over here, and then somehow the expected value to small exception was not thrown, meaning that we can reach to the next line. In that way, we say error, right? So this is the logic for the test. I'm just hand-waving a little bit just to give you the big picture, and then we're gonna trace the code right away. All right, guys, do you have any questions so far? 2 things to notice. Number 1, you want to know what the expected behavior is for the scenario. We create a counter, check its value, and then try to decrement. That's the scenario. Think about what's the expected behavior. We expect some exception to be thrown. number one. Number two, you want to think about the two different scenarios. Either the decrement was implemented correctly, what's going to happen? Or if the decrement was implemented incorrectly, what's going to happen, right? When you consider the JUnit test or console test, you are the tester. Your job is just to focus on testing, all right? All right, hearing no question here, why don't we try to do a little bit of tracing over here, right? I got two scenarios for you. So this one is more like a warm-up for everybody. For the console test number two, it will be more sophisticated. Okay, for this one here. This is the implementation. And of course, this is the test, right? It's kind of obvious, just to make sure you see the difference. And in this case, this is something we are given to test. And I can tell you that in this case, this condition here is correctly specified. So that's scenario number one, all right? Just write it down. In this case, it is correct. Or you can also see from the title here, it's actually correct, all right? Especially here. Let's now try to trace the code very quickly, and I'll run also the Eclipse at the end. We try to create some counter objects over here, and the initial value will just be 0, right? And then we try to print line, system and out print line. Initial value c.getValue over here, it would just give us 0. That one's okay, all right? And then we go into the try block, and we try to go for c.increment over here. Oh, sorry, decrement, beg your pardon. And this one here, we're going to execute here. The current value will just be 0 for the counter, right, initial value. And if you recall, the minimum value is simply 0. It's a constant, right? 0 equals 0 is true. That means we're going to throw that exception as expected. After this, that means from this line over here, we're going to see it will throws value too small exception. And then we're going to get this disrupted for the execution flow. So this part here will be bypassed. For the rest of the try block, it will be bypassed. And we go to the catch block that lists the relevant exception over here. And then we're going to execute everything that's in the catch block. In this case, we're going to say success. That expected exception there was thrown. So that's the execution flow. Are we okay with this? So the only line that turns out to be skipped by this test is just this guy here, which is okay, because there's no error. Right? So that's scenario number one, when the given implementation was correct. Okay, let's do scenario number two right away. And I'm going to do that explicitly here. We're still given some implementation here for decrements, but let me modify that. So rather than having equal over here, let's say the implementer was careless. They simply put less than. That's obviously wrong. That is to say, only if the current value is strictly less than 0. And am I going to throw that particular exception? For example, I will only throw the exception when it's -1, but that's too late. We should throw that exception when it's 0, right? So apparently this is wrong implementation. Let's emphasize that. Let's say this is what you're given. So this will be implementation that's incorrect or wrong. And let's say we are running the same test over here, but on some incorrect implementation. A good test should really tell you that there's something wrong. Let's see if that will be the case, okay? Again, we're going to trace line by line. Initialize the counter, and when we're trying to print the value, c.getValue should really give you 0. That part is okay, okay? And go to the try block. When we try to execute decrements over here, if we step into it, the current value for the counter will be 0. And the counter minimum also 0. 0 strictly less than 0 is false, meaning that we're going to bypass throwing the exception. And we're going to execute the else part over here. And we're going to decrement the value from 0 to -1. Obviously, that's wrong, right? But let's see how the test will actually react to this. So that means at the end of the execution for this method call over here, the expected value to small exception was not thrown, right? But how does the test catch that? Because no exception has been thrown, the execution flow is not disrupted. We'll just go to the next line. And then we go into this line here, and it's going to say error, value to small exception, not thrown, but it was expected, right? And then the rest of the, the catch block, apparently, it will be bypassed. That's the execution flow. You really want to make sure you understand the difference between this one here and this one here. Quick recap. Scenario number one, the implementation given to you is correct. Scenario number two, it was incorrect. And both of them can be handled properly by the test, by executing different execution paths. And we're we have seen this execution path before on Monday. Any question so far? Anything that's not clear, you'll be now the time to clarify, because console tester number two would be way more sophisticated. I shouldn't say way more, just more. Okay. Kevin. Sure. If you look at the implementation here, we're basically trying to say, we try to decrement the counter, right? But there is a potential, because the counter value cannot go below its minimum, which is 0. So that means if the current value for the counter is already reaching its minimum, you cannot really decrement, right? So that's why the correct implementation should be, when it is equal to its absolute minimum, you should really tell the caller, no, I cannot do it, value too small. On the other hand, the wrong implementation would be, for example, you only try to throw that exception there if the value is strictly less than minimum value, in that case, -1. Right? So that's why it's incorrect. For counter test, okay, this scenario number one, the console tester here, and also scenario number two, the counter tester here, they look the same tester we are using. Right? I'll just show you different path. For correct implementation, you're basically going to get into this catch block and report success. And for incorrect implementation, you're going to reach the next line over here and report error, because the expected exception was not thrown. Right? Yeah. All right, guys, is it clear about everything? I hope. All right, good. Okay, let's do the challenge, the second one. But before that, let me see if I missed anything from the slides. Everything has been just discussed. And notice that when you study the slides, especially on your computer, notice that for slide 10, for example, so there is a link over here. It says, see the equivalent but automated JUnit test decrement from minimum value. I'm not too sure if we might be able to get into this test today, but later on when you study, I try to compare the console tester versus JUnit tester. Logic-wise, they're really equivalent, but the way to do things are slightly different. That's why I want you to contrast. All right, just remember. All right, so that's version number one. Let me see if there's anything I missed. Sorry. Okay, so this is also very important. The real value of a test is not just to confirm your implementation is correct. Also, if the implementation is incorrect, you shouldn't give a green bar, right? Just remember, these are the very rules of the thumb. Yeah, as I said before, for this course, you wouldn't really get a chance to get evaluated for writing JUnit tests. You will only be required to read the JUnit test cases. But I'll encourage you, when you do your labs, try to write your own test cases. I think it's a very nice opportunity to practice. Okay, that'll be my recommendation. Once you get to the later course, for example, EECS2030, software design, I think you will be more responsible for writing your own test cases. But why not practice earlier? All right, so that's incorrect versus correct. And then, okay, so that's about version one. I think I already covered everything. Just notice that also in the slides, I talk about execution path over here. Just pay attention to that. Okay, version number two. Okay, so what should we do for version number two? All right. Again, if you don't mind, I'm going to ask you to spend, this one I'll give you maybe 2 minutes. Okay, you might want to spend a little bit more time. Take a look at console test 2. I'm afraid this one is a little bit more complicated because you got nested try and catch. Take a look, and then I will try to decipher for you. I'll give you 2 minutes. I think the highlights there in orange, green, and pink, they might help. Okay, give you 1 more minute, especially you want to somehow convince yourself. For example, let's say line number 17. What does it really mean if the execution path will eventually get to 17 and print out the error message? Does it really make sense? Right? That's what you want to convince yourself. There are 3 such lines to really convince yourself about. All right? All right, another 30 seconds, and then we'll try to decipher the mystery. Okay, just 1 more moment. Okay, any one of you would like to try, just informally, what is this test trying to do? Marcus, why don't we start with you?
Well, it's just going to see when the value too large exception is going to be thrown, or if it's even going to be thrown in general. So it starts off making the new object that's number C, and then it'll print out the current value. When it gets to the first try, it's going to increment 3 times, which is within the boundaries. So it's not going to throw a value too large exception there. So it won't throw that orange one. And then when you go into the second try block, it's going to continue on. Then when you increment it 1 more time, it's going to throw the value too large exception, meaning that it's going to throw the success.
Okay, pretty good, thank you. All right, let me just try to repeat what Marcus just said. He actually said it very correctly, all right? And let me try to help you at least clarify the confusing part, which is about nested try and catch. It is absolutely allowed to have nested try and catch, and this is just one example, okay? How do you understand it? Think about what I'm gonna highlight in yellow over here. This part here is the outer try and catch block, this part over here. Okay, so we got try here, and we got catch over here. That's the outer one, all right? There's another inner one which will serve different purpose, but let's just highlight them quickly. All right, so this one here, try and catch over here. This will be the inner one over here, and this will be just another one, all right? And there are reasons for why we need nested rather than parallel try and catch block. There will be some exercise for us to think about later, but it's for later, not for now. All right, it's nested. First of all, make sure you understand we got nested try and catch block, outer one, and also inner one. Let's now try to understand the intuition of the test, and then we'll try to trace. We got 3 cases to trace, all right? We create a counter as before, and then we just want to make sure the initial value here by our eyes, right, is going to be printed to the console is 0. We enter this outer try and catch block, and just let me make some notes here for you. At this point, let me use maybe purple, okay? At this point, right before we call the first increments, the value for the counter should be 0. Agree? After the first increment, but before the second one, the value should be 1. After the second, but before the third, it should be 2. After the third, it should be 3. And first of all, let's understand. All such increments, all the first 3 increments, we wouldn't expect any exception to be thrown. Agree? Because value is still incrementing within the bound, so we are still fine. All right? So for this part here, no exception should be thrown. But what if any exception was thrown, either from the first increment or from the second increment, or from the third increment? if some unexpected exception was thrown, in that case, the flow will be disrupted right away to this corresponding catch. And then we're going to say error, that exception was thrown unexpectedly. Right? That's the first scenario to remember. But we'll trace that together. Right? Number one. And let's move on. We get to the maximum value for the counter already. So we're going to see what the current value is. Of course, it should be 3. Okay, so just say this should be 0, and this one here should be 3. All right? And then we're going to enter this inner try and catch block, meaning that you can think about the reason that we just need a separate try and catch block is because now our expectation will be a little bit different. When we were doing these 3 over here, no exception should be expected. But when we do this one here, some exception will be expected, right? You can see our expectation is changing, which is okay, right? Let me write it down. It is so important for you to see the structure of this code. Out of these 3 over here, no value too large exception expected. Number 1. And when you try to do this 4th increment over here, you will expect the value too large exception expected. And think about this blue one, the blue try and catch block over here. Think about this one here. It's basically following the same logic as we just talked about for console tester 1. Just remember. Okay, let's still go over that quickly. When we try to increment, we do expect the value too large exception to be thrown, in which case we're going to go to the catch block over here, and that will say success. Otherwise, if the implementation was somehow incorrect, in the sense that it's still going to proceed to the next line without throwing that expected value too large exception, in that case, we're going to say error. Notice that we got 2 possible errors from the test. So that's why this test is actually so nice. It's so fine-grained. Either the error could be the expected exception was not thrown, or the error could be you didn't expect the exception, but it was thrown. There are 2 kinds of error in this test over here. Right? Just be careful. That's only just about some very general overview about the structure for the test, so you're clear what we're going to do. Any question before we try tracing the code? Stare at that for 1 more minute. That's okay. You know, if you got any question, it might be now good to actually clarify before we actually move on. First, please. Is there, oh, sorry, I don't quite catch you.
Is there any scenario where the header can occur, like, for example, let's say the value too large exception for unexpectedly. So is there any scenario which could lead to that?
How about we try to trace this code for the 3 scenarios? Maybe that will answer your question. I think just need some concrete example. Yeah. Hey, guys. Oh, sorry. Please. Thank you. Yeah, Kevin, please.
For the outer catch, so
You mean the inner or the outer?
for the outer catch.
Outer, okay.
I'm trying to understand, like, can you explain that?
Sure. The outer catch, of course, it will be clearer once we also try to trace the concrete example, but outer catch over here. Think about outer catch goes with the outer try, right? So here we are saying that this part over here, we do not expect any exception to be thrown, because we're incrementing 0 to 1, 1 to 2, 2 to 3. They're still legal. If there's any exception that might be thrown from this 1 to 3 increment here, then there should be an error. That's the reason. Yeah, that's the rationale. For the inner try and catch, the expectation will be flipped, because now when we do the 4th increment over here, we do expect that exception to be thrown. So that's why if it's really thrown, in that case, yes, that's right. Okay. Yeah, why don't we try some examples? Example number 1, correct implementation. All right, that one's the easy one to just warm up for this variant here. All right, you can see here it is correct implementation here when the counter value already reaches the maximum over here. We definitely cannot do any further increment, right? So this is correct. All right, correct implementation. All right, let's now try to trace it. Create a counter here, and print out its value, which will be 0. And again, you check by your eyes rather than assertions, right? And let's now go into the first try and catch block, this one here, right? And then we try to do increments one by one, okay? Let's say for the very first one. When we try to do this first increment here, we're going to check this condition here. The current value for the counter will be 0. 0 equals, what's the maximum? 3. 0 equals 3, false. So we're not going to throw the exception. And then we're going to increment the value from 0 to 1. That is why the value here will be go from 0 to 1. Are you okay with this? Okay. The same similar pattern is going to go on, which I'm not going to bother you. So from 1 to 2 and 2 to 3. You're just going to execute the same check 3 times. All right? So we're going to get counter incremented to 3. And then when we print out the value for the counter, it's going to be 3 over here. All right? So far, so good, because it's correct implementation. It did not throw any exception unexpectedly. Right? You can think about this part here was bypassed implicitly. All right? And let's now try to do the inner try and catch block. And then we'll go into this line over here. We try to do a 4th increment. At this point, right before it, the value for the counter is 3. And then when we execute this over here, the counter value is 3 equals the maximum value 3, true. So that means we're going to throw that exception over here, indeed. So that means this line over here is going to throw that value too large exception. And what's going to happen is the execution flow will be disrupted, and we just go directly to the catch, right? And once we go to the catch, we're going to print out success over here. That's going to be execution flow, right? Let me highlight it once more, and then I can take some question in case you got any. So we start with this, do each one of them, and do this, and it was interrupted, do the catch, and that's it. What I highlight in green will be the execution path. Any question? Now would be the time to ask. Yes, please. Sorry, let me just get closer. Can you say that again, please? Sorry. It's a very good question. The question was as follows. Imagine the following, guys. Very good question. Let's say this try and catch block over here, right? Imagine that rather than being nested inside the outer try and catch block, what if we move that outside the try and catch block? So that means we got try and catch followed by try and catch. What's going to happen? That's one of the exercises we'll do in just a moment. Yeah, I think everybody should really think about it as well. All right, we'll get there. Bear with me. All right, let's now do another 2 cases quickly. All right, so now let's talk about incorrect implementation number 1. Right, we got 2 possible scenarios for incorrect implementation. Let's say we, let me just put it here. Let's say that we change this from equal to less. What does that mean? That means whenever I wanted to increment, as long as the value is lower than the maximum, I'll just throw the exception. You just throw the exception prematurely, basically, right? Too early. Let's see what's gonna happen. Apparently, that's incorrect. This one here is incorrect. All right, let's now trace the same counter. Initialize the counter, and then also we try to check its current value, right? It should be 0. This part's okay. Go to the outer try and catch block, and then before the first increment is going to be 0. And then we're going to step into see that increment for the very first time. Too bad. You see, here, when we go there, current value is 0. Maximum is 3. 0 less than 3, true. That means this poor incorrect implementation will throw the exception right away. Apparently, that's wrong, right? What's going to happen is this, after his, is going to throw value too large exception, meaning that it's going to interrupt the execution flow to here. Oh, by the way, just in case you're wondering, when the execution flow is interrupted, why wouldn't it go to this catch block? You might be wondering, right? It's because this particular try block goes with this catch block. That's why if anything that's thrown, you will go to the outer one, right? Just remember the highlight I did earlier, all right? Once we get to the catch block, we're going to say error. It was thrown unexpectedly. And let me highlight the execution flow for now. This line here, apparently the try, this one here, only that one. And then we get to the catch block over here, and then we print out the error, right? So that'll be the execution path. That's for incorrect implementation number one, in which you throw the exception prematurely, just too early. Not the right timing. Either you can throw the exception too early or too late. We're going to see one scenario where it's too late. Any question about this? All right. Third one. And let's try. For the third one, let's now modify the implementation a bit so that's incorrect. Let's say larger than. What does that mean? That means when we try to do increments, I will only try to throw that value to large exception if the current value is already larger than the maximum. Apparently, that's wrong. That means, for example, the maximum 3. I will only throw that value to large exception when the counter value is 4. Apparently, it's too late, right? That's apparently incorrect. And we're going to trace it as well. Why don't I give you guys just one opportunity here, just 30 seconds. Imagine, to picture in your mind, you don't need to do anything in writing. How is the execution path going to proceed for this code over here if we try to test this increment over here? Think about it, and then I'll confirm in writing. All right, let's try together, right? Hopefully you at least thought to yourself. Let's try to trace line by line. Create a counter, print out its initial value, which will be 0. We go to the outer try and catch block, and then we try to do the increment one by one. For the first one, starting with 0, so if we do increment over here, 0 larger than the maximum value, which is 3. That's false, so we don't throw that exception. Right? So that means we're going to increment the value successfully. So from 0 to 1. And you can definitely keep going for the tracing. You will go from 0 to 1, 1 to 2, and also 2 to 3. Right? So for this part, it's the same. Okay? So far, so good. And then we're going to go to this line here, and then we're going to say what the current value is. It should be 3. So far, so good. No error has occurred so far. And then we're going to go to the inner try and catch block over here. And then at this point, value is 3. All right? And we do expect the exception to be thrown as a tester. So we go into this block again. So now value is 3, larger than the maximum, which will be 3. 3 larger than 3, still false. So we wouldn't throw it. Now really, so we still go to the else part. We're going to increment it to 4. So this part here is going to be 4. At the same time, you wouldn't throw that exception. Agree? The expected value too large exception not thrown. In which case, we're going to go to the next line and print out the error. After this, you can think about implicitly this will not be executed, and also this part here will not be executed. Let me highlight the execution path. This one may be slightly tricky, but you want to make sure you follow through. 1, 2, 1, 2, 3. This one here, try, and this one here. And then we go to here. That's it. That's the execution path. We talk about all the three scenarios. Scenario 3, Scenario 2, Scenario 1. They all got different execution paths, right? All right, guys, any questions so far? So these are very nice case studies about how the exception can be used. Again, let me remind you the big picture. Whenever you're testing, the expected outcome could be that exception might be thrown, or it could be that exception is not expected to be thrown. It depends, right? Study this example very carefully. Any question? Okay, if no, I would like to pause just for a little moment here. There's a little tradition I usually like to do right before the reading week. Apparently in the past 2 years, it was a pandemic, so I couldn't really do this in person. Before the reading week, I like to play some magic trick to my students for 2030. But that somehow that magic is related to programming, okay? Before I show you what the magic is, I need 2 volunteers. Marcus, how about we find 1 boy and 1 girl? Marcus, you'll be the... Okay, all right. Okay, Abby, Marcus, come over. Okay. Yeah, I'll get it ready. Okay. Okay, and Marcus, Abby, just get ready. I'll explain how this is going to work. I implemented some program, like my magic assistant. Okay, I'm going to launch the program there, and then I will let Marcus and Abby. They're going to, well, while they're working out which number to, well, let me show you. You know what? Let me just start this, and then I'll set it up. I'll launch the program over here, and then let me maximize it. Am I spelling your name correctly? How do I spell your name? Abby? Okay. Notice that the program is still running, right? There's no way for the program to know what exactly they're going to choose, all right? So now, what's going to work is I'm going to step outside, all right? Marcus and Abby, they're going to choose 1 card from this display here, 1 card. And the principle is they can let everybody here know. Don't state it out, so that I will over here. Right? I'm going to step outside. When you guys are done, either Abby or Marcus, just please grab me from outside. And don't tell me what the card you have chosen, right? Just choose 1 card. Make sure everybody knows. Don't take too long, okay? Just 1 minute or so. You done? Okay. Guys, you know what the card is, right? Notice that the program was never interrupted, right? So there should be no way they will know what you guys have chosen. Okay, so now I will need your help. Since everybody knows what the card is, let's now start the game. The idea would be I only need to ask them 3 simple questions and get the answer, and the program and myself, we will know what the card you have chosen. All right? Tell me which column. Column 1 over here. Column 2 over here. Column 3 over here. Which column? 3. Everybody agree? 3. Somehow, the cards have been shuffled in some way. You can think about it more like a random. Second question, which column? 3, agree? Everybody? Okay. Of course, I'm assuming that you're being honest to me, right? Yeah. Unless you want to make me feel embarrassed at the end. 3, right? Am I right? 3? Just confirm. 3, thank you. Final question. It has been further shuffled. Which column? 2. Thank you. Marcus and Abby, now I know which card you have chosen. Is that right? Guys, magic. All right. Thank you so much, Marcus and Abby. Thank you so much. Please. All right, so not just to play the magic. So the main lesson I want you to get, not directly relevant to this course. This course is about OOP. This one is not really about OOP, right? It's more about programming, right? So what we have just illustrated, it's not just magic. It's really based on some math, okay? I'll give you a little bit history about this puzzle over here. I used to be a York student in the same department. So it was back in maybe 2003 or 4, around that time. I was taking this EECS2030 algorithm course with Jeff. You know, he's still here. He's a very good professor. And then he actually showed me this kind of logic in pseudocode, just in the conceptual level, to explain some mathematical concept. And I decided that maybe I just turn that into some Java code. And it can be done quite elegantly using some array, two-dimensional array, and etc. Okay? So now, here is my challenge to you. I'm going to send this link to you guys. You can also, you already know how the program works. There is a site for card trick for kids. All right? This site here, very brief, it shows you how you're supposed to play the trick. When I say the shuffle is random, it's not exactly random. You have to somehow shuffle the cards in a way that's going to help you reveal what the card is. Okay? So here's my challenge to you. This is not a bonus question. This is not an extra credit, not. For those of you who might be curious to take out this challenge, use the reading week or any other time. Look at this website. It shows you how to implement stuff. And when you're done, approach me. What I will do, I will look at your code, give you some extra comments, and then I will also explain to you the mathematical idea behind. Only for those of you who might want to try. All right, guys, that will be my little challenge for you before the reading week. Okay, I will love to see how many of you might end up approaching me by the end of the semester. Okay, I'll send you the link when I release the lecture today. Okay. And let me just go back over here. All right, let's now go back to the real life, right? Let's now go back to lecture. So what I want to do now, let me see. Why don't we do one Eclipse demo very quickly. If you go to the project I released for you, so you can see there is one project called example testing counter, right? I'm going to release a project to you. And I will encourage you to really try to use the breakpoint and debugger to reproduce the kind of tracing I just did. I'll do one together with you, and you will get an idea how to do the rest. Just one, all right? Let me clear that. And let's say we do for counter tester number 2, all right? For this one here. And notice that for this counter here, it's using the counter from the implementation package, right? Let's say we want to reproduce this scenario. Let me just show to you which one. And then we'll do some exercise. How about we do this one here, okay? Let's say we try to reproduce this particular scenario. Of course, we have to make sure we gave some wrong implementation by using less than, right? Let me show you how you can reproduce it. Let me just go back here to the Eclipse. You can go under implementations package and go to counter. And then the value too large exception here, that's the correct one. So now I'm going to switch that to less than. Right? So that'll be the wrong implementation, right? Before I run the tester. Right? You can see under increments, I'm going to change that to be less than. Right? And we're going to reproduce what we said over here. Okay? Let's now try this. If you go to counter tester number 2, and I'm going to put a breakpoint right in the beginning over here, line number 8. And let's launch the debugger. And for this time, I'm not going to step into just to save time, but at least we'll see how things go. Maybe I should say, oh, okay, just a little bit slow. Sorry. Let's say switch. Okay, line number 8, we're here. And then let's now try. Okay? If I say step over, that's okay. That's fine. And we go to the outer catch block, right? And as we know, the first 1 to 3 increment is not going to throw any exception, right? We can say step over. Oh, did I change something wrong there? Let me see. Let's try to debug again. I may have changed something that's wrong. Counter over here. Increment, and then, oh, I think you're right. Sorry, it was right. So, beg your pardon, just forgot about what I just said in the last 30 seconds. Let me do it again. I just do it again. Let's go back to the console tester here, and then let's launch the debugger once more. Okay, there we go. And remind you very quickly, that's why I was confused. Remember what we did for this scenario here. Basically, what's going to happen is you're going to throw that exception prematurely, too early, right? So that means as soon as you try the very first increments, because the value will be 0, 0 less than maximum 3 will be true. So you throw the exception right away. That's what you're going to see, right? Just remember. Okay, let's confirm that. If we do step over, and right before we execute the first c.increment, let's step into just for this one. If you step into, you can see now we got this wrong implementation here. This value currently is 0. Maximum value is 3, so this will be true. So if you say step over, you're going to throw that exception. Agree? And what's going to happen if I say step over again? This line here is going to throw that exception. So that means you'll bypass the rest of this particular try block. And then it's going to go to this catch block and then print out the error. That's what's going to happen. All right, let's try. Let's go back here, and then we're going to say step over here. That one there, you can see we bypass the rest of the try block, and then we go to the catch. And this one here is going to step over and print out the error. All right, that's what you will see from the tester. And notice one thing. So far, we're only doing system and out the print line. So it's not exactly automated, which can be done by JUnit. That's something we'll get into. All right? All right, so I'll encourage you to really try to reproduce every scenario we spoke about for counter tester 1 and counter tester 2. All right, I just showed to you how you can do one. Okay, good. And let's do one exercise over here. Okay, just make sure we got some time here. Okay, so this exercise is exactly what you asked before. All right? And let me remind you very quickly. If you look at the tester over here in the beginning, you can see here, we got the nested try and catch, right? We got 2 try and catch blocks, but somehow they are nested. How about the following? Let's say we still got 2 try and catch block, but they are not nested within each other. Rather, one after the other. Now the question is this test itself correct? I'm not asking about the correctness of the counter. It's not an issue. I'm asking whether this test is going to do what it's supposed to do. Basically, you want to think about, is there any scenario where we do expect something to happen, but it wouldn't be reflected somehow in the test, somehow? I would suggest you stare at this for a moment, at least understand the structure here is different from what we had before because it's not nested, and this will be my hint for you. Use that hint to check to see what's going to be the behavior for the test, for the execution path, and then ask yourself, is that really correct for the test? Okay. For this one here, you can, we are not really talking about whether implementation might be correct or incorrect. You can think about all the scenarios to see if there's any particular scenario where it's not going to work. Yeah. Okay. It's worth thinking about. So I think this is really nice because I'm pretty sure you might be wondering, when should I use nested and when should I use not nested? The answer, I'm afraid, will be it depends. In this scenario here, it turns out nested will be the only way to go if we got console tester. All right? But I'll let you just think about it for 30 more seconds using the hints. Try as much as you can, and then I'm going to discuss. Maybe I'll start with you since you asked the question. You can let me know how you think. If you have anything to share. If no, that's okay. I can ask somebody else. 30 seconds. Okay, so we say, what if one of the first 3 increments over here, okay, without telling you the answer just yet, we what's going to happen to the tester? And then you want to think about what's going to happen for the entire execution for the tester. That'll be my further hints. Does it click on you for this one? Or anything to share? Otherwise, it's okay. You can pass it. Yep. Exactly. Yeah, that's basically correct. All right, guys, let me tell you the answer. Okay, in this one here, it is not correct because as soon as the tester itself identifies an error, the tester didn't really terminate right away. If something that goes wrong, you must interrupt the execution flow, including the tester. But this one wouldn't do it. Let's see how. Okay. So this would be my argument for why this would be inappropriate tester. Okay? Let's make the following assumption. Let's say this increment over here is incorrect, let's say. But in what way? Let's say this increment over here, let's say incorrect so that the value too large exception thrown prematurely. Okay, let's say. What's going to happen? Let's say the exception is actually thrown. So you'll be caught over here. Okay? And then it's going to execute this. So far, what's the execution path so far? This one over here, this one over here, this here, this one over here, and also the catch, and also this. So far. Now the question is, given that an error has been identified already, is the tester still going to proceed? It is, because it will still do this part over here. This is not really escape. That's the issue. Not skipped. Even if an error has been identified. Okay, over here, right? And let me go a little bit further. Why would this matter? It is possible for certain mysterious implementation, let's say, you still go on to do a 4th increment. For some reason, the increment itself is going to now throw the exception. So you will actually also get success. In that case, the tester is going to print out error and say success. Isn't that confusing? The implementation is both correct and incorrect. As you learn in logic, P and not P is contradiction, right? Well, anyway. So, this one here. If this line was also printed, it would be contradiction. Okay, because you got both error and success, right? So that's why when you're using just system.out.print line, you have to use a nested. Try and catch. Right? That's an exercise. And later on, possibly we have to do this maybe after the reading week. But after the reading week, when we revisit this example here, we'll see the corresponding JUnit version that's gonna use assertions. We don't really have to nest it. We don't really have to nest the try and catch block. That's something I'll talk a little bit more detail after the reading week. But I do want to talk a little bit more today before I let you go. All right? Any questions so far about this exercise? Everybody's okay? Okay. I hope it's not too heavy today. I hope. Okay, let me see what's next. Okay. Okay, that's version number 2, which we spent quite a bit of time about, right? Again, there's also on slide number 14, there's also some contrast you can also do. Just click on the link and you will see. All right, just don't forget. Right, that's really good for you to compare different versions. All right, we'll talk about the 3 different scenarios for version number 2 already. And that's the exercise we just did. All right. And I want to give you a 3rd version. Okay, 3rd version is rather straightforward. Let me just go directly, just go over with you the structure. Okay. So we got version number 3. This one here is to say, in version number 2, for example, we have a very specific scenario. We say we want to increment 1, 2, 3, and then 4 times. And in console tester number 1, we actually got just try to decrements when you actually got initialized some counter. It's not very flexible in some way. We would like to have some very quick typing when we actually want to do the testing. What do I mean? I'll illustrate to you. Let's look at console tester number 3 to see how flexible it could be. Okay? Still, it's a console program. I'm going to demonstrate to you on Eclipse as well. Basically, you allow the tester to choose what commands or what method they want to test. Either they want to get a value, or they want to increment, or they want to decrement. Let's see the code structure. We still got some counter objects over here. Right? Let me highlight the part you should really pay attention to. There is a counter that we are trying to manipulate, and then we're using a Boolean variable to control the entrance into the loop. That's something we already talked about last time, right? For that one, I'll just let you study that. So that one allows the user to say, as long as the user enter increment, decrements, or get value, you should let them keep testing until they say exit, basically, right? For that part, I'm going to let you study. You get either increments, decrements, or value, either one. And let's look at this try and catch block over here to understand what it is trying to do. Try and catch. And notice that we got multiple catch blocks, which we talked about last time, right? Basically, in this fragment of code here, we basically try to make method calls that might throw either value too large or value too small exception. That's why we need multiple catch block. All right? Where are they? Let's take a look. You can see here we got C dot increments. So this one might throw value too large exception. What about C dot decrements? May throw value too small exception. That's why you want to make sure you handle both of them properly over here. All right? That's why you got multiple catch blocks over here. And then depends on what the user want to test, you will simply call the corresponding method. And then you're going to print out what the outcome is. All right? Let me illustrate to you how you're supposed to use it. Go back to Eclipse. And then let me switch back to Java. Okay. And then we're going to go to counter tester number 3. All right, that's the one. And let me launch it. Run as Java application. All right, let's illustrate that very quickly. Okay, now, oh, sorry. Let me do it again. That's the one I want to maximize. All right, imagine that I'm not a tester. Right? I'm now testing whatever implementation I might have. So now I can say, what's the current value after the counter has been initialized? Value, 0. And I may say I want to decrements. Now, what should be the expected behavior? That value too small exception should be thrown. Right? If I say decrements, enter, value too small. And we know that the fact that we actually got this error message printed out is because the value too small exception being thrown over here is because we actually got this exception being thrown. So that's expected, right? And then we can just keep going. Let's say we want to increment the value, no exception being value to be, oh, because I already changed the implementation in the counter. That's why it will throw prematurely, right? Let me just, for completeness, let me just do one more thing to show to you, right? Just always remember the version of the implementation you're changing. Go back to the counter, and I'll change this back. right? Of course, when you're testing the counter, if there's anything that's not within your expectation, the implementation might just be wrong, all right? Let me just do one more time, okay? So I change it back to be correct, and then I'm going to just show you very quickly. You can say, okay, the value initially is 0, increment once, value becomes 1. Increment twice, the value becomes 2. Increment the third time, the value becomes 3. What about I want to try to increment fourth time? Expected outcome should be the value too large, exception should be thrown. Indeed. Right? That's exactly in that corresponding catch block. And then if I want to exit. All right? So that's a third counter tester. Okay? That one there, you can see it's quite nice. You can actually do it iteratively about the testing, but still quite limited because it's manual. All right? What I would like to do in about 7 minutes is I want to jump slightly, since we're going to get a one week gap before I see you again. You definitely will need this. Well, you pretty much got all the grounds you need for lab number 2. I want to talk about 2 examples quickly, and then we'll pick up from there to finish everything after reading week. Okay, 7 minutes. Now, what I'm going to do is I'll show you for counter tester 1 and 2, which we did by system and out the print line, try and catch, etc. What will be the corresponding, how would the corresponding JUnit test version look like? That's something I want to show to you. All right? Let's now take a look. Let's now look at here. And if you counter tester number 1, that's something we just did in the beginning of today. Right? That one there, I don't need to repeat. And this would be the corresponding JUnit test. All right? Again, as usual, I would like you guys to maybe take a look yourself. All right? You know what? I don't mind if you do the following. I'll give you 2 minutes. Do the following. Brush up your mind about how counter tester number 1 look like, number 1. Number 2, look at how this corresponding thing look like. Try to convince yourself if they are equivalent, and then I'll explain. Okay? 2 minutes. This will be kind of the pattern you will see quite often in lab number 2 and in your programming test number 2. So it's good to learn that now. All right. You might just be able to see very easy correspondence, but I'll let you observe that yourself, and then I'll just confirm. Okay, 1 more minute. Okay, let's see the correspondence. In the case of error, this is in the console tester. In the case of the JUnit test, we simply say fail. All right, that's a correspondence number 1. And this particular JUnit assertion called fail is actually quite useful. What does it really mean? That means to fail the test, the current test, which is this particular test, right away. Because we have discovered some error, so we should really fail the test right away. Right? That's correspondence number 1. Correspondence number 2. Well, we used to say success in the console tester here, and now we simply have a comments. It's almost like a do nothing. Okay? And this is also important for you to know about JUnits. Do nothing. Because a JUnit test without, number 1, assertion failure or without exceptions So here I've talked about any kind of exception. If there's simply no exception thrown unexpectedly, and also no assertion failure, the test will be considered as success. I'll illustrate one point to you right away. Would pass. Guys, it's a very important point here. Let me just repeat it and I'll illustrate right away. A JUnit test without either assertion failure or without any exception, it will be considered as a pass. What do I mean? That means you can create the most dumb JUnit test to make yourself happy in the following way. How? I will show you too. Let's go back to JUnit test, for example. Okay. And under tests, we got test counter, right? Take a look at this one. Oh, let me just create right away. Put a test tag. This is something you did in lab 0. Public, void, dump test number 1. I simply do nothing. When I say do nothing, there's no chance to have assertion failure. There's no chance to have exception. Would it pass? Funny enough, it would. Run as JUnit test. And then you will see over here, everything passed, and the dump test is just over there. And not too sure if you ever try to do that. If I want to make myself happier, I can create another 2 and 3. I can just increase the number of tests in my test package, and then now I got number 3. And then you can see rather than having 7, now I got 10 test cases, and all of them actually pass. Right? You see my point? My point is, every time when you see some green bar from the JUnit test over here, right, it doesn't really mean it's 100% safe for you. You have to make sure you know what you're doing. Because in order for a single JUnit test to pass, it's quite easy. Just do nothing. All right, just remember that point. All right, let me go back. And then I'll be done in just 1 minute or 2. And then I'll definitely let you go in time. If you review this one here, let me just make the final point. This one here, the logic goes as follows. I do some assertion over here to check the value for the counter, right? And then I do expect some exception to be thrown from here. If it was, it's actually going to go to the catch block. And then I simply do nothing so that the test will just pass. Number 1. Number 2, if the expected exception was not thrown, in that case, I will be able to reach the next line, in which case I'm going to fail the test because that expected exception was not there, right? The logic here is exactly the same as what we did for the console tester. So we just have to know how to do the corresponding replacement. In the written test, and especially for your written test number 2, you have to make sure you know about how to do counter tester in the console versus in the JUnit, okay? All right, so just take 1 more minute just to tell you what you can expect. I'm going to release your lab number 2 either by the end of tomorrow, Thursday, or early Friday. So you can work on that in the next 2 weeks. And number 2, I will tell you the slide number you should really study during the reading weeks. Because once we come back, not next Monday, but the Monday after, I'm going to finish off this lecture rather quickly. We already covered all the basics. You know everything already. I just need to do a little bit more example to highlight. And number 3, I'm still going to host an office hour during the reading week. For those of you who just want to take the chance to catch up with the basics, you can still might be the best chance to talk to me if you want to. All right? All right, guys, thank you. Enjoy your reading week. Do take a good break, and then I'll see you when we come back.